Given a candle, a box of thumbtacks, and a book of matches, and asked to attach the candle to a wall so it can burn without dripping wax on the floor below, most people struggle for a surprisingly long time, fixated on using the tacks to pin the candle directly to the wall. The solution, emptying the tack box and using it as a candle platform, tacked to the wall, is blocked by a specific, well-documented cognitive bias, functional fixedness. Functional fixedness, first systematically documented by Carl Duncker in the 1940s, is the well-established cognitive bias in which people perceive an object rigidly in terms of its traditional, most familiar function or use, making it substantially more difficult to recognize and generate novel, creative alternative uses for that same object, even when a novel use would provide a more efficient or even necessary solution to a problem at hand. This bias reflects how strongly prior learned experience and habitual categorization can constrain flexible problem-solving. In Duncker's classic candle problem experiment, participants were given a candle, a box of tacks, and matches, and asked to mount the candle on a wall without dripping wax onto the floor below, with the solution requiring the insight that the tack box itself, rather than only its contents, could serve as a candle platform mounted to the wall. Duncker found that when the tacks were presented already emptied out beside the box, rather than inside it, participants solved the problem significantly faster, since perceiving the box empty and separate from its usual tack-holding function reduced functional fixedness toward the box specifically. Mental set, a related but broader cognitive phenomenon than functional fixedness specifically, describes the general tendency to persist in applying a previously successful problem-solving strategy or approach to new problems, even when that approach is no longer the most efficient or effective available option, or is entirely inappropriate for a specific new problem's actual structure. The classic water jug problems, in which participants asked to solve a series of problems using one specific formula, continue applying that same complex formula even to later problems solvable through a much simpler approach, demonstrate this phenomenon clearly. Developmental research finds that young children show measurably less functional fixedness than older children and adults when tested on comparable problem-solving tasks, a finding consistent with the theoretical explanation that functional fixedness develops and strengthens as an individual accumulates more extensive learned experience with objects typical, conventional functions throughout childhood and into adulthood, meaning the bias reflects a genuine cost of experience and learned categorization rather than a fixed, universal cognitive limitation present from early development. Deliberate divergent thinking exercises, in which individuals practice generating as many alternative, unconventional uses as possible for common everyday objects, have been shown in controlled studies to measurably reduce subsequent functional fixedness and improve performance on novel problem-solving tasks requiring creative, non-obvious object use, suggesting that functional fixedness, while a robust and default cognitive tendency, can be meaningfully counteracted through deliberate practice, specifically targeting flexible, multi-use perception of familiar objects. Beyond formal divergent thinking training, several practical strategies have research support for helping overcome functional fixedness and related problem-solving blocks in everyday contexts, including deliberately taking an incubation break, stepping away from a difficult problem for a period of time, which appears to allow unhelpful, fixed initial framings to fade from working memory, and actively seeking input or perspectives from people with different backgrounds or areas of expertise, who are less likely to share the same specific, deeply ingrained functional associations for the objects or concepts involved in a given problem. Functional fixedness reveals that the very learning and categorization that make everyday object use efficient and automatic can simultaneously become a genuine barrier to creative problem solving when a novel situation calls for seeing familiar objects in an unfamiliar way. Understanding this trade-off and the practical strategies that help counteract it offers real, actionable insight for improving creative problem solving in any domain.